To all of you joining us in North America, and good evening to those of you who are joining us from Australia. I know we still have people hopping on right now, but I am Tiffany Wenrick. I am the chair of the LRW Education Committee, and I'd like to welcome you all here today. And before we get started on our extremely interesting presentation today about Rio Tinto's Autohaul, I'm going to go ahead and take care of a few housekeeping items while we continue to have members join. First of all, there are two ways to listen as you hop on. So it'll ask you to join with computer audio, but if you prefer to have a phone connection, you can click on your little headphones icon or your microphone icon, whichever one you see, and select dial in the audio pane, and that should give you dial-in information to join via phone. You can submit questions at any time by using the Q&A chat. You'll see a Q&A tab on your control panel. We'll keep an eye on those, and we will answer all of our questions at the end of today's presentation, or as many as we can answer, and we'll do our best to get you answers offline if we don't get to your question during today's webinar. And this session is being recorded, and it will be available on the LRW website to members and via email to paid attendees. LRW does have a code of conduct. At everything we do, we expect everyone to be professional, courteous, and kind to one another. And if you experience anything aside from that today, you can go ahead and email webinars@railwaywomen.org to let us know. And then the last thing from me, thank you so much to our corporate partners. This diverse group of organizations across the rail industry allows us to do things like today's webinar. And being a corporate partner or a member in general gives you access to just a really talented, diverse group of women and all the knowledge and resources they have. It gives you access to our educational webinars like today, our in-person events, our career board. There's networking opportunities, professional development opportunities. We just restarted our mentorship program. So a ton of different benefits to being a member and specifically a corporate partner. If you are interested in your organization or yourself to join as an individual member, you can visit railwaywomen.org and click on the Join LRW tab to see all of the various membership options. That's enough for me. I'm going to go ahead and turn it over to Christine Khalil. She is our co-chair for the Education Committee.
Hi, everyone. So as Tiffany said, I'm co-chair for the Education Committee and also a director at large for the League of Railway Women. And today I have the pleasure of introducing two of my colleagues from Rio Tinto, Carmela Mucciolo and Jessica Mitchell. Carmela has been in the rail industry for over 13 years, with extensive experience working on complex rail projects in both passenger in Italy and heavy haul freight applications in Western Australia. Carmela started working on the Autohaul project in 2013 during the early development phase, and she is now the superintendent of testing and deployment for the rail engineering and strategy team. As part of her current role, Carmela manages the testing activities, logistics, and execution of the Autohaul software enhancements. Carmela aims to continue developing personally and professionally as an engineer and as a leader. As a way of passing on her passion and experience in rail, she has also become a mentor for the Australian Railway Association's Women in Rail Mentoring Program. And Jessica Mitchell is a graduate control systems engineer working in the Autohaul team. Jessica joined the Rail Engineering and Strategy Division at the beginning of this year, and she is focusing on the overall communication structure, which is vital to the operations of trains in the rural Pilbara region in Western Australia. And now, without further ado, I will hand it over to you, Carmela.
Thank you, Christine. Thanks, Tiffany. Welcome, everyone. Good morning in North America and good evening to everyone that had the pleasure to join this meeting at 9:30 in the evening. So good effort. Thank you. Today we're gonna talk about Autohaul, but with different perspectives. So we have introduced a fully autonomous train operation at Rio Tinto, but we want to look at that from how the automation impacted our workplace, our people, and our operation and safety. So let's start with giving you some next slide, please, some input on what is Rio Tinto, a business. So we have been mining for the last 150 years. We started in 1873 in Spain with a copper mine, and since then we have grown so much that we're now operating in 35 countries. We have different type of mining. We mine aluminium, copper, various mineral, including the red diamond, the pink diamonds, which are my favorite. But I'm gonna focus today on the operation in the Pilbara, so in Western Australia. Next slide, please. So I've put a little map of Australia there to let you understand where our operation is. So it's in the north of Western Australia, in a very outback and desertic area. It's called the Pilbara region. And we operate all our network, which is roughly 1900 kilometer of rail from Perth, where we have our operation center, which is a center of excellence and cutting edge technology. So we run all our trains from Perth, and our further, we have 17 mines. 15 of those are operated with driverless train. 2 are still operated with the previous system that we call legacy operation with drivers on board. We have 4 ports. We have 57 train set, and each of our train is composed by 3 head-end locomotive and 240 wagons. When it's loaded, this train weight 217 US tons, which compares to roughly 100 elephants. That's what it is, the comparison there. And for that, we won the Guinness World Record as the heaviest robot in the world in 2020. So going into, please, next slide. If we want to just look at our journey as a railway, we have been operating in the Pilbara region, starting at Tom Price Mine in 1966, so 60 years ago. We started mining there, and we had a long journey to reach the automation that we have currently now. We started with the introduction of the ATP later in the 90s, and then we moved with new braking with new system. We improve our braking system. We improve the way we manage the mine site. We introduced multiple steps of advanced technology up to the automation. So I'm gonna show you in the next slide, please, how we reach the Autohaul goal. So to actually operate autonomously such a big network with so many trains, we had a vision, and we actually started our automation in the early 2000s, and we did do a prototype, a sort of initial trial. But unfortunately, in 2008, 2009, due to the global financial crisis, we had to stop that. But our vision didn't stop. So we really wanted to go autonomously. So what we did, in 2012 is when we got our partnership with Hitachi, that was called Ansaldo at the time, WebTech, another vendor, and we started this amazing journey. But Autohaul didn't come overnight. We had to, first of all, update our rolling stock. So we have 221 locomotives. All of them needed to be upgraded. That started in 2013. And then later on, we introduced the ECP, so which is the electronic controlled pneumatic brake system. And then later on, we finally start in 2015 to run our new signaling system, still with the driver on board. And I'm going to talk about that more in detail later on. But we couldn't just switch to driverless operation because our our operation is 24/7. We constantly run train, we never stop. So we couldn't just introduce Autohaul like a big bang. We needed to stage it. And so what we did, we ran with a driver on board, but not driving the train in what is called attendant mode for we did more than 1,000,000 kilometers in this mode of operation, where a driver was just in attendance of the train, making sure that the train was actually doing what it was supposed to do. And then finally in 2018, 10th of July, we ran our first autonomous operation. But we didn't stop there. After we introduced other enhancements, for example, some of our mines, for the position of the mines and the fact that the loaded train are so heavy, those trains needs to be banked. So we introduced autonomous banking operation later on in 2021, and just recently this year we bought new consist with ECP standalone. So we are always looking at new technology and advancing our operation. So next slide please. To understand Autohaul, first of all, I want to show you two things: why we've done it and how we've done it. That's very important. So first of all, safety was our goal. To run this operation, you have to see that our cycle time normally is 36 hours for a train to go from port to mine and come back. But a driver can only drive for 12 hours. Is a shift that goes door to door. From the moment he leaves his camp to the moment he comes back, they come back, they can only run for 12 hours. And therefore, it was very stressful and very complicated to manage the changeover between drivers. Just imagine that if driver one was on the train driving, at some point he needed to stop, and a second driver following the train with a car in a light vehicle would just go and relieve the first driver, and the first driver would go back. So there was a lot of driving involved. And driving it also includes fatigue, and our people were fatigued, and driving in this type of environment is very dangerous. So with people at our heart, we thought that the safety was the primary concern. And so with the introduction of Autohaul and the fact that the driver don't need to be on a train for 12 hours, we saved 1.5 million kilometers per year of traveling on light vehicles. So this is a massive saving. Massive saving also in fuel, in diesel, because imagine 1.5 million kilometers per year. Also, in terms of safety, when we decided to go with Autohaul, we chose the best standard practice, that is the Senelec. The Senelec is an European standard for software development process. They guaranteed a level of reliability or a level of integrity, a level of safety for the subsystem that are part of this, part of the overall Autohaul system. So we, first of all, safety, we said, lower the risk for our people, and then improve productivity, of course, because without a driver on board and with the system fully automated, with the computer driving the train, what we achieved was a better cycle time, a reduction in cycle time, and so that improved productivity and reduced our operating cost, also because we were saving so much fuel. On top of that, what we have achieved is to be recognized as leader in this market, as the pioneer in the automation for railway. And therefore we create this partnership with other vendor, and other vendor are approaching us, showing us the technology that they're gonna be putting on the market. And we wouldn't have access to that if we didn't do Autohaul in the first place. So it's enabling our future growth as well. So next one, please. Thank you. So I spoke about, next slide. Thanks. I spoke about the, no, sorry, the previous one. I spoke about the why we did Autohaul. I'm going to talk to you about the how we did it. So you can imagine with such a massive operation running 24/7, so many kilometers of tracks, so many trains running all the time, we have to upgrade our system. And what we touched was fundamentally 4 subsystems. We improved our onboard locomotive, so we installed new equipment such as the ATP, automatic trip protection, that control the speed of the train, can give you the speed restriction in real time, and can control the way the train is handled and managed in terms of safety. We added the driving strategy engine, which is the computer that controls the throttle and the dynamics of the brakes. And the most important, the core part of Autohaul is the automatic train operation control, the ATOC, which is pretty much the computer that communicates with the control system down in Perth with the operation center, and is the computer that acts as a driver. So we'll ring the bell, sound the horn, all those things when the driver is not on board. On top of that, we installed cameras on the locomotive to be able to detect any collision and send back the video to the operation center so that the train controller could make a decision, inform a decision if the train could safely continue its journey or not. I'm going to talk about that later on a little bit more in detail. In terms of signaling and Y-side, we did massive improvement, but most importantly, 2 things. The obstruction detection system and level crossing, where we can actually detect obstruction and stop the train before you reach the level crossing, and all the asset protection, which are fully integrated in our system. The alarms are sent to the operation center, and then the train is brought to a stand in a safe way, in a place where it can be inspected properly by a driver. So those are the 2 massive things on top of any other additional Y-side, additional signaling. Then we touched on our operation center, where we installed what is called in Europe the radio block center, which is for us the vital safety system, which managed the movement authority for the train. So it's really the brain of the Autohaul system. It's the system, it's the subsystem that controls all the movement authority of all the train connected on the network and decides which route is safe and when the movement authority can be given to a train. On top of that, of course, as I mentioned, the operation center is very far from the Pilbara region where we operate. And so we needed a very robust communication system where we could have a strong data radio, strong. We had to manage satellite as well. We have mobile mobile broadband. We count on all those systems to make our communication pathway reliable. Next slide, please. So as I mentioned, we run 24/7, and 15 of our 17 mines, they run autonomously with no driver on board on the train, but 2 of those are still running with a driver. And therefore, we couldn't just switch overnight from the old system to the new one, but we needed to run in parallel. So what we did, we physically installed a switch on each locomotive that will go from one mode of operation that we call legacy, which was the existing one, before the enhanced mode of operation, which is the Autohaul one. So we installed another system at the OC, which was the interface between the existing subsystem controlling the signaling, the microlock, the signal, the route, the TCS, what we call the train control system, and the new enhanced VSS and ATP, which is what we call the automation server. So that interface allowed us, together with the switch on board, allows us to switch between two modes of operation, the legacy and the enhanced. So in the legacy system, the movement authority is given to a train via cab codes that are transmitted via the rail. And in this mode of operation, the driver is fully responsible for driving the train at a certain speed under certain condition. And the train controller needs to talk to the driver constantly and inform them if there is a new temporary speed restriction, if they have to slow down, if there is any impediment on the network. The only way is a communication, but that includes human error. Instead, in the enhanced operation, what we have the vital safety server, which controls the routes, gets information through our communication system, gets information from the Y side and determine if that train can continue safely and what is the speed that that train needs to maintain. Most importantly, in the enhanced operation, the train will just give the driver the information that is the next target location is, for example, the next target is, for example, a 40-kilometer speed restriction. So the driver needs to slow down. And if it doesn't, the system will intervene and will apply the service brake. So it's extremely safer and doesn't rely on the driver to listen to a conversation on the radio with the train controller, but relies on a person reading the screen and driving according to the prompt. Next slide, please. So this is the signaling part of it. Now goes to the Autohaul modes that we have. So as I said, it wasn't possible to implement such a complex and cutting edge project in a small amount of time or without going through phases. So we went through phases. We staged our project. You can call it the agile approach because now it's very much used everywhere. But at the time, it wasn't that in use, but we did use this staged approach where we actually have 4 modes of operation on board. So once the enhanced operation is active, as per the ATP, as I showed you in the previous slide, we have the ATOC, which I talked about before, which is our, it's the computer that controls the train, that can have 4 modes of operation. In passive, when the driver is still on board, is fully controlling the train, is fully driving the train, but the information to the driver are given by this new signaling system, VSS and ATP. So the driver directly gets all the speed restriction and any condition that is applicable at that time on the network. The driver assist phase instead, the second type of operation, is when the driver gets also some prompt on all the upcoming information. So it can see multiple speed restriction ahead, for example. So it can control his driving according to what is coming up next. Then we have the attended mode of operation, which is the driver is not driving the train, the system is driving the train. So it's fully automated. However, a person is still on board, which can be a driver or a driver with a tester, and is just supervising the behavior of the system. So this is a key mode of operation that I want to stress. This point is very important to me because I manage testing now, and we use this mode of operation every day in testing because otherwise we couldn't test new piece of software or new enhancement that we do all the time. So the system can get updated, and under a test regime, the driver is on board with a tester and the system drives the train, but there are witnessing there and they are supervising that the software is actually behaving as expected, as per the requirements. And then the final train, the the final phase, which is autonomous or unmanned, uncrewed, whatever you want to call it, is when there is no driver on board and the train is fully automated. So this was our final goal, and this is what we have achieved going through those stages. Next slide, please. So I explained to you, I've given you a lot of information, but I'm just gonna make it easy and more visual what happens with a driverless train, how we set up what we call our autonomous mission. So at the port in the yard, the driver has a set of wagons ready there. He shunts the loco in front of those wagons and then prepares the train for the autonomous mission. When the train is ready and all the steps have been done, the driver confirms with the train controller that the train is ready and hop off the trains. So calls the train controller. The train controller, as I said, they are located in Perth, and they can actually, they are in control now of that mission, that train for the entire journey. So they then set the route for the train, they give a start, and the train is ready to go. And it drives autonomously up to the mines, the destination mine. At the mine, there is no human intervention there. There is an automatic handover between the Autohaul system and the train loadout operator. So the TLO, train loadout operator will load the train, and once the train is ready on the departure road with all the cars full, then the system will also automatically reconnect from the train controller that the train is ready to go, and will restart its autonomous journey back to the port. So all of that is done without human interaction. However, we don't have a driver on board, so who is checking all the alarms if there is anything critical, if there is anything that happens on the loco and there is no one there to tell the train control about it. So we have two type of roles, both train controller and ascendant evaluator, who are constantly monitoring the system and all the alarm that are sent from the train to the operation center. What happens is that the system is smart enough that if there is an alarm that is deemed critical, then the train will stop, and a driver, a network locomotive driver, will need to attend that train and restart the mission, or potentially drive it back to the port in a passive mode, so with the driver on board, because the fault is too critical. But if the failure mode is something that can be tolerated and just needs maintenance when it arrives to the port, then the train controller and the ascendant evaluator will consider the circumstances and the alarm and will let the journey continue. So just so you understand, the train controller gets information such as also the collision detection of the obstruction at level crossing. All those information are sent from the Y side or from the train to the operation center. So it's the train controller that is fully in charge of that train journey together with the ascendant evaluator rather than a driver now. So next slide, please. What I guess we have done a lot of improvements, but as I said, we have removed the driver from the locomotive. So that is the last resort, the last control in the line of fire. If there is an obstruction, the driver could see the obstruction and stop the train. If there was an indication from an asset protection that the train was dragging something at the back, the driver will hear it probably and stop the train and inspect the train, or any other asset protection. So what happens? We had to think about how we could improve our system, make it safer without a driver on board. So some of the risks are collision or impact a level crossing, the asset protection alarm going off, all this sort of thing. So we have fully integrated our Autohaul system that is capable of responding in an automatic way to all our asset protection, including the hot bearing, hot wheels, is responding automatically to any impact, such as a collision with animals or anything like that. It responds automatically in the sense that if is an area where the train needs to stop, it will stop automatically. Otherwise, we will send a video to the train controller. The train controller will decide based on the collision event if it's safe to continue. Also, we have integrated all our level crossing that have some sort of interaction with the public. We have integrated that with the ODS system, which is something I'm going to talk to you about later on, so in more detail. And most importantly, we have the DSC, our driver strategy engine, which controls, as I say, the throttle and the dynamic of the train. And we've seen a big improvement. You can see in the graph over there, that is a section, 20 kilometers of section, and this is driven by a driver. This is time frame, and you can see the reduction when it's driven by Autohaul, by the DSC, rather than the driver. So all those improvements are for safety primarily. Next slide, please. So I'm gonna talk in more details of the obstruction detection system, while Jessica later on will talk about the collision detection, how it works now and what we are planning for the future. So our ODS system, obstruction detection system, it's installed at all our active crossing, which are 42 on our network. So an active crossing is a crossing that has some interaction with the public. As I said to you, this is the Pilbara region is a sort of remote area, desert area, but we do have our network runs close to mine towns or close to some highways or roads that are that have some public traffic. So those road or those area that cross our network are the riskier are just some of the major risks that we had to consider during our during the initial phase of Autohaul. So the first thing we did, we just had a lot of risk assessment process, and we determined which were the major risk. And the collision at a crossing was one of the biggest concern that we had. And before we installed this system, which is fully integrated, and what it does is based on camera, a laser scanner. It could be a dual crossing or a single crossing. So depending on that, we have other 2 laser or 4 laser. And it scans that area, the detection zone, to determine if there is any obstruction. If an obstruction is detected, an alarm is sent to train controller, plus the movement authority of the train is reduced to a virtual signal that is the whistle board, which is 400 meters from the crossing. So if the train is far enough, it will just stop at the whistle board. If the train is already within the braking curve, the braking time is still stopping much quicker than a driver could do, because you see, it doesn't matter how far the train is. If there is an obstruction is detected and the train is communicated that there is an obstruction, so the movement authority is reduced, or a brake application or brakes are applied. So this is very safe. It's much safer, and of course, once the obstruction is clear, the train can depart and continue its journey. So I guess, can we go to the next slide, please? Just so I guess It depends. Our project was very intense, very time consuming, quite expensive, and we reached a full scale autonomous train solution, which potentially is not applicable, or it doesn't suit all type of operation, because some operation, some railway cannot afford full automation, or don't want to go that way. However, some incremental benefit could also be reached using some of our subsystem, or some of the idea that Autohaul has put on the market now. So, for example, the vital safety server is something that allows the operator to know exactly where the train is, to control the movement authority, control the speed, and is safer in terms of managing the operation of the train. The ATP itself, what we have, it's a system that protects the locomotive, and it's capable, as I said, of controlling the speed of the train, and the driver has to follow what is on the screen, otherwise it gets an intervention. So it's safer to have that type of operation rather than not having it. The collision detection system, it's a system that allows you, with the use of camera, to see if there was a collision and what happened, and if it's safe to continue or not, or if you need to send a crew to recover that train. All these things that we have implemented can give some sort of improvement, either on safety, on productivity, on reduction of the operating cost, to multiple or different type of railway. This is our freight operation, so it's quite different from passenger, for example, railway. But some of those features, for example, the obstruction detection system, are extremely good and can be used on other type of railway. So this is just an overview of all the subsystems that could potentially improve any railway. The next slide, please. So this is just a summary of, we talked a lot about safety, but how reliable is this system? So this is a summary of how much we have done since 2018. So we ran 33 million kilometers in autonomous. We had a successful rate of 98%, which means that those trains were running in an autonomous mode. And even if they had some sort of intervention and the crew needed to attend those trains, they could continue their journey autonomously. And we had less than 4%, of train running where the driver needed to attend the train, and other continued the journey driving the train, or just let the train go after the issue was fixed. So this is quite a good, reliable system. But let's talk about now, next slide, please, about what happened with our workforce. So it's at the very beginning of the project, no one really believed we would achieve this. So as I said, it was very complicated, and not everyone likes changes. So there was a sort of discomfort in seeing all those changes and what they will mean for both train controller and drivers. So we have retained most of our drivers because we have created what is called the response hub. So we need drivers, and we usually have 2 of them in each of the response hub, which are around our network. We need the driver to be there to be ready to respond to any unexpected event. Could be mine related, could be a spillage, or it could be Y-side related, could be an issue with the train. So a driver needs to be in a position that they can quickly attend the train, check, inspect the train, for example. It could be a not bearing, an asset protection, a not bearing alarm. So someone needs to inspect the train. That's our driver. And will inspect the train, confirm if the alarm is real or if it's a false alarm, and then let the train go, or shunt some locomotive, or do whatever is required to do. But of course, the role of the driver has changed. Can we go to the next slide, please? So what we've gone from a person that was constantly driving a train, so having a certain skill set, to a person that has become more a technician. A role has been modified so that this personnel now knows more about the system. They need to know how to make the system work again, what to touch on the loco, what to do on all those computers, which button to press, but also they need to maintain their skill set for actually driving the train, because there are circumstances, and it's less than 2% now, but there are circumstances where those drivers are required to drive the train back home because the train can go autonomously. There is a critical alarm, or there is not enough power or anything. So the role of the driver has been modified during the year, and one of the struggle was to be able to maintain their skill set. So what we've done, and I think that's very important to share, because when you do change management in a project as complex as this one, people must be the first goal. People must be at your heart, and you need to understand that if their role changes, they need to be aware of the change and embrace this change. Otherwise, the operation wouldn't work at the end. So what we've done, we have created, after the implementation of Autohaul, we have actually started using different tools. So we are doing a lot of classroom training. We're doing a lot of on-the-job training. We're doing web-based package for new, for refresh training or for new started. We're doing a lot of detailed training plans and assessment. And most importantly, all our drivers are still required to drive our locomotive in the yard where they set up the train. So we give them enough skill to be able to drive, to rotate through the driving, so they can maintain their skills in the yard. So they will be able to respond to a train. So I guess, I think we have the next slide, please. So I wanted to share with you, and I think I'm on time for that. Before I pass it on to Jess, she's gonna talk about our future and some of the fancy things that are coming on in the next few years. So I want to show you this video, which is a video of our first ever driverless journey, which was 10th of July 2018. I wanted to show you this because I want you to see what I've explained so far. So I want you to see how big this train is, and I wanted to see the environment where we are operating. So it will give you an idea, a better understanding of what I just talked about, and then we'll be open for question later. Thank you so much.
First loaded autonomous train from Tom Price to Cape Lambert, our next step towards full-scale autonomous operation of the railway.
Very excited, can't believe we finally got to this day.
I would struggle to count the number of people that have been involved in this process. This project's been going on for the better part of a decade in various forms. It touches lots of parts of our business, so I would say it'd be in the hundreds.
My role today is to set up a driverless train, check that it's done safely and ready for departure, liaising with train control, and then to stand clear and send it on its way.
My process involved with the driverless train today will be talking with the Autohaul crew to make sure the train is presented to train control ready for departure. And once they've confirmed that that's the case, then we'll proceed with our Autohaul scenario to make the train take the journey through to the ports.
I'll liaise with train control in Perth and we'll do our tests.
98 West Control, if you're right to validate your data.
Roger.
And 8198 West Control, data's validated and Autohaul start doing.
West Control 8198, yeah, got Autohaul, mate. And then I'll exit the cab and train control in Perth. They'll program the train and it'll go to the coast unmanned, and this will be the first event of a heavy haulage loaded train from a mine to a port worldwide.
I think it will change how quickly it happens. We don't have to worry about changeovers. I just think going forward, it's a big business improvement.
I originally would get there, and you know, I'm really proud to be part of the technology, and you know, it's a huge, huge milestone in global rail operations.
It's great to see a train coming. We dreamed it, and now finally we made it. And I think it's really a big recognition of the big effort, all of the team, of united team of Rio Tinto and Ansardo STS.
We're making history today.
It's a very moving video, that one. I think we hope that it would kind of draw attention to how remote and isolated our operations are and how impressive the whole project was. So hi everyone, my name's Jess. So I'm a graduate control system engineer in the Autohaul enhancement team with Camilla. I'm very grateful to be talking alongside Camilla today. As I'm sure you've already gathered, she has a lot of knowledge to share. I'm just going to go straight into it so we can get to questions. So today I'm going to be talking about the future of our railway. So that includes improvements in safety, technology, and our pathway to decarbonisation. So on the screen here, you can see some footage from our collision avoidance system trials. So that's catering to the improvements in technology we're hoping for. But before I go into that, I'll tell you a bit about our existing collision detection system. So this detects whether collisions have occurred and sends that information back to the Perth Operations Centre. And this detection is done via sensors on the cowcatcher. So for those of you who are confused by the term cowcatcher, I believe you might use the term snowplow. We don't get snow here in remote Pilbara of Australia as it gets very hot. We do, however, have a number of cows crossing our railways, so I'll let you draw your own conclusion on how it's gotten its name. Looking to the collision avoidance system trials, the aim of this is to give, at the end of the day, Autohaul is a robot, and we want our robots to have vision. Because the locos are heavy haulage, sometimes it can take up to 1 kilometre to stop the train after an emergency brake is applied. So this vision we intend for Autohaul, it needs to be able to see far enough in front on the track so that the Autohaul can make a decision effectively and rapidly to stop a train
in time to prevent a potential collision. So key questions we wanted answered from this trial was whether we could detect a person at night, whether we could see a person in variable terrain, and if we can see a person on track 1 kilometre in front. So moving on to the next slide, please. So you can see the first system we trialed here featured cameras on the top of the loco cab. So this system uses a variety of different lens types, from short to long range, infrared and thermal, to interpret digital imagery of what's happening on the track ahead. So you can see some of the actual camera footage on the screen. It's pretty impressive, able to see that far ahead and inside the tunnel. Another consideration we have is, again, because it gets very hot, these systems can sometimes be affected by extreme heat, and this is a less bulky design, so it could be a good feature to create an engineering solution such as a sun shelter, just to prevent some maintenance, which is good. So next slide, please. So the second system we are trialing is on the screen here. So this one uses 2 vision cameras, and they are narrow and wide fields of view. So you can see here, it's able to look 1 kilometre ahead and around a bend to see a car on the track, which is awesome, very impressive. So we're currently finished with the 2 trials of these systems, but with many applications of the technology already in existence, we believe the integration of the system responses is going to pose more of a challenge than the technology actually proving itself. As Camilla has mentioned, there are a number of subsystems that belong to Autohaul, and with this collision avoidance system, it's adding a new complex system, and actually integrating that into the existing systems is going to be a little bit of a hurdle, but I'm excited because I think my team will get to deal with it, so I'll get to have a little play with it, which is cool. So this technology is going to have to use AI to distinguish between objects, know which objects to avoid, such as people, cars, and trucks. And then upon making this distinguishment of the object, the train will need to make a decision of whether to keep going or to stop the train. And this decision must be made rapidly so that the train has enough time to allow for its braking distance to avoid that potential collision, which is cool. Next slide, please, Christine. Yes. So on the screen here, you can see our pathway to decarbonisation. As many of you are probably aware, a lot of countries and companies have set themselves a net zero emissions target for 2050, and Rio is no different. But our key challenge here is how to do this across a completely diesel-powered network. So in the short term, we're looking to improve our current operations, and Autohaul has helped with this with the reduction in cycle time. However, this is nowhere near enough that is required for that 2050 target. In the medium term, we're looking at biofuels and other sources of fuel for our consists. And then in the long term, we are considering battery electric locomotives. We're conducting a rigorous proof of concept in 2025, and that will trial some bells through our harsh conditions and our heavy hauls and test them out and see how they go. So on the screen here, you can see the end goal is to have a solution across our entire supply chain. And you can see various touch points such as charging stations at the port and mines, and then alternative power sources available such as solar and wind, which we get a lot of here in the Pilbara. So I know Rio is open to everything, as the aim of this challenge is to find a solution that will work for us. And I'm very excited to have started as a grad, and I get to be a part of this journey. So next slide, please, Christine. So lastly, what's the future of our railway? So on the screen here, you can see our 2040 rail strategy, which outlines a number of initiatives that will help us reduce emissions and improve safety, as well as help us continue to serve as that critical link between port and mine operations. As was mentioned, a lot of the work I'm currently focused on is to do with communication systems. And as Camilla said, the Autohaul locos are constantly communicating from the Pilbara back to Perth Operations Centre. So that's equivalent to 1,527 kilometres. So that's about 950 miles or for those of you who need real world pictures, that's about from Montreal to Wisconsin. So it's quite a far distance, and we need that communication to be reliable. Otherwise, Autohaul has issues. And then so with the addition of each of these new complex systems comes more data and information that needs to be sent from that link from Pilbara to Perth. And that pushes us to increase the bandwidth of our communication systems, and means I get to get my hands dirty and get involved in other solutions, which is pretty cool. And then so we believe the future of, and then also because this is in remote, it's quite hard to get all the infrastructure along that 1900 kilometers of rail. So I'll wrap it up there. We believe that the future of mining is bright, in particular rail, and I'm very happy to be a part of such an interesting and long-lasting project. And I look forward to my future on this journey with Autohaul. We'll go on to questions if that's all right.
A few minutes left here. I do apologize. Normally the webinar cuts off very abruptly at 10:30. We'll see if we can keep going with the questions. If not, we will make sure we get these answered and posted somewhere. So the first question we have, with the autonomous trains and haulage trucks being controlled out of Perth, has Rio Tinto been able to attract employees with families who would not normally be able to fly in and fly out?
So I'll try to be brief. I read those questions in advance, so I'll try to answer all of them. So in terms of people, we had a lot of movement with our people. That is, for example, a person that was based in Pilbara before, there was a supervisor of the network locomotive, and now he joined the train controller down in Perth. He moved his family down and he's doing the supervisor of train controller. Completely different, but his skill set are helping to improve also the understanding of the train control level, how they operate the train in Pilbara. So there has been a lot of movement, a lot of attraction of other people outside or inside the organization to move around and have different role. We have taken care of our people, and whoever wanted to move, we usually allow that independently of Autohaul. We support movement of people depending on their personal situation and family. But this is just because Rio, at least my experience, they're very family oriented. So that's really, it's not just Autohaul, it's in general. The other one, there are two which are about camera and laser scanning and everything. So as I said, the signaling system and all the upgrades have been done in stages. So we started in 2012, but that was requirement phase. And since the beginning, we had the requirement for something to be, for the obstruction and level crossing to be sent back to Perth. Then we started the installation. Well, we did everything in stage. We have 42 level crossing. We didn't do them overnight. We were going stage by stage. At some point, we were running off the network in passive, and then we had to switch to the old signaling system because the rest of the network wasn't validated yet. So it took time and effort and staging phases. Then there was another part about the lenses and how you clean them and what to do. So we had to be creative there because Pilbara is a very unforgiving environment, super hot. We get weeds all the time. So we had to have regular cleaning. Like the guys are physically going there every 2 weeks during spring when it's raining and it's hot. That they're cleaning out the weeds and spraying everything and trying to protect the camera. Otherwise, you get full obstruction. And we got that for a long period of time until we fine-tune all of those systems. So yes, there is a lot of maintenance done, and our maintenance strategy has changed. One thing I haven't mentioned in my presentation, but is very important, thanks to the new DSC, to the fact that we can drive the train in a more controlled way, we had less broken train. We had a minimum number of broken train, but the maintenance of the system is huge. We got so many new systems installed, and each of them needs maintenance, and it could be like a 60-day cycle maintenance, could be 6 months, it could be 3 days, like cutting weeds and things like that, and maintaining the lanes clean. So I think I've got to few of those
Looks like we haven't been cut off yet, so I'm going to go ahead. I'll
okay.
The different types of repairs do you find you have with the locomotives that are in autonomous
Yeah,
operation?
this is what I just said.
Okay.
Yeah, this is the one I just. But how many more years of mining are supported by the resource there? 60 years so far, right? Incredible. Yeah. Yes. So we are. We're always looking for new mines and for new way to improve and make our product good. So this is something that I'm not so familiar with. It's not about systems, it's about mining itself, which I do rail. I don't do mines, but yes, there is still ore and we can still mining it. So yes. Tonight, what percentage of your operation emission has been lower with the switch to Autohaul? Look, in terms of percentage, I'm not sure. What I know is the data I haven't personally done the calculation in terms of emission, but we have saved that much fuel. So 1.5 million kilometers per year, and it's been 5 years of fully autonomous operation. So do the calculation. That's pretty awesome in terms of diesel consumption and emission due to light vehicle, which are just big, massive 4-wheel drive in the desert. So I guess we did quite well through the question as well. I'm not sure
Thank you
if
so
I
much.
answered fully
Yeah.
the question, but yeah.
I appreciate it. Thank you so much, Carmela and Jessica. It was great to have you today.
You.
And I know I learned a lot. It's fascinating work that you do, and excited to see, you know, that pathway, Jessica, that you were talking about as you continue down. So quickly,
thank you
LRW,
for having us.
Yes, absolutely.
Yeah, thank you very much.
For LRW, there's a couple more in-person events coming up shortly here. So the Southwest Association of Rail Shippers, apologies, meeting is in San Diego on the 26th to 27th. We'll be there. And then October 1st to the 4th is Railway Interchange in Indianapolis. And in conjunction with RSI, we have our annual conference there. The LRW does with some great programming. So hope to see you there. Thank you all so much for joining us, presenters, attendees, moderators alike. We appreciate you, and please, connect with us on social media. Visit our website if you're, interested in any more events or becoming a member. And thank you all for joining us today. Have a great rest of your day and night for those of you in Australia.
Thank you. Bye.
Bye.